Welcome to the May 2025 update on the Milwaukee Estuary Area of Concern Dredged Material Management Facility. I am Bridget Hank. I am a Senior Project Manager with the Milwaukee Metropolitan Sewage District and the lead project manager for this project. Today we're going to talk about the Milwaukee Area of Concern, just a refresher on what that is, a refresher on our sediment removal, and then we'll talk a little bit about our Dredged Material Management Facility, both the design and then our construction to date. Starting with our Area of Concern refresher, in the 1980s, 43 degraded areas were identified by the United States and Canada as areas of concern. An area of concern has at least one beneficial use impairment, which means that the water body has undergone a change in its chemical, physical, or biological integrity. The United States and Canada areas of concern are shown on the map on your screen. In Wisconsin, we have 5 areas of concern. We have the St. Louis River, the Lower Menomonee River, Lower Green Bay and Fox River, Sheboygan River and Harbor, and the Milwaukee Estuary. On the map on the right shows our Milwaukee Estuary area of concern. The water bodies are shown in gold and the watersheds shown in blue. The water bodies include the Kinnickinnic River, the Milwaukee River, the Menomonee River, and the Milwaukee Bay. Milwaukee became an area of concern because of our years of heavy industrial use along our waterways. We were formerly known as the machine shop of the world. This meant that a lot of heavy industry was located along our riverfronts and our lakefront, and they ultimately used our waterways as open sewers, discharging chemicals, waste products, heavy metals, and that sediment is still in our waterways today. Addressing that contaminated sediment will make our waterways better for both humans and wildlife. Unfortunately, we can't go back to those industries because they're no longer here. So the federal government and our non-federal sponsors are working together to remove that contamination from our waterways as part of our delisting of our area of concern. In order to delist an area of concern, you need a lot of partners. And these partners are calling ourselves the Waterway Restoration Partnership. They include local governments, the federal government, non-government organizations, nonprofits, and pretty much anyone who's involved with water in southeastern Wisconsin. If you want more information on the sediment removal and the work that we are doing as part of our AOC delisting, go to mkewaterwaypartners.org. Sediment removal is a key component of delisting our area of concern. This part of the project is being led by the EPA and is in the feasibility study phase of the work, which means that they are starting to develop the plans of how exactly they're going to remove the sediment. The EPA is leading the effort for sediment removal, and they have identified several areas where sediment will need to be removed. They've done sampling of that sediment, and they are starting to put together the planning for how the sediment will be removed from each of these sections, how it will be accessed, and what to expect during the sediment removal. Go to the mkewaterwaypartners.org for more information about the specific sediment removal in the colored areas shown on the map on your screen. The majority of the sediment is planned to be removed using something called a hydraulic dredge. This essentially is an underwater vacuum that sucks up the contaminated sediment from the bottom and discharges it through a pipe system directly to the Dredged Material Management Facility. In some areas, we can't use a hydraulic dredge, and we will use a mechanical dredging operation, which is more conventionally known as the clamshell that grabs the sediment and puts it on a barge to dewater and then loads it onto a truck and hauls it over land to the DMMF. More information about the hydraulic dredging and mechanical dredging can also be found on the mkewaterwaypartners.org website. Now that we've talked a little bit about the area of concern and the sediment removal, we're going to move into talking about the Dredged Material Management Facility, or DMMF. The Dredged Material Management Facility is designed to hold 1.9 million cubic yards of sediment and floodplain soils removed from the Milwaukee, Menomonee, and Kinnickinnic Rivers and the Milwaukee Bay. It's proposed to be just north of the existing sediment facility and south of the Jones Island Water Reclamation Facility and Summerfest. It's shown on the map in blue. In 2020, we began the design, and in 2024, we began the construction. We anticipate the construction to be completed in 2027. The Milwaukee Metropolitan Sewerage District began our part of the Dredged Material Management Facility construction with a concept plan. Initially, the concept had only two walls, one on the north side of the facility and one on the east side of the facility. Originally, it was proposed to be a cellular cofferdam system with each of the interlocks of the steel sealed to provide the contaminant containment throughout the facility. In early 2021, MMSD did a request for proposal for the final design services. In December of 2021, the Dredged Material Management Facility final design contract was awarded to Ramble Engineering Americas right here in Milwaukee. The first task for the Ramble team was to look at existing facilities in the area and on the Great Lakes, and we came across a facility at Randall Reef in Hamilton Harbor in Ontario, Canada, that was very similar to what we had proposed to build here in Milwaukee. We had some very collaborative meetings with the Randall Reef team and were able to even tour the facility this July. The proposed dredged material management facility is located in Port Milwaukee, just north of the existing facility. On the east side, we have the navigational channel. On the north side is the liquid cargo pier, and on the west side is the existing dock wall. What that means for our proposed facility is that on the west side and the south side, we only need a single wall of steel. The existing facilities serve as the other side of our facility. On the north and the east side, where there is existing lake, we need two rows of steel. So we'll have a north interior wall and a north outer wall. And then we'll also have an east interior wall and an east outer wall. These walls are considered a combination wall and will be a combination of king piles or circular piles and steel sheet piles, which are the Z-shaped piles that you see along our existing dock walls. The construction of the facility began in April 2024. The contractor is Michaels, who is also based here in Milwaukee. They're doing the majority of the work from barges on the water. You can see two of those barges along our north outer wall in the photo in front of you. You can also see some of that combination wall. So we have circular piles with sheet piles in between them. The contractor is putting in the circular piles first and then coming back and putting in the sheet piles. So if you take a look over at the north wall, you can see just the circular piles without the sheets in between them. Each one of the circular piles, or king piles, is 4.5 feet in diameter. They range from 60 feet to 85 feet long. You can get a real scale of how large this pipe pile is based on the two workers that are at the base of the pile. You can also get an idea of the scale based on those white lines along the side. Each one of those is a foot. So this is showing that this is a 60-foot long pile. It's being installed by a vibratory hammer. So that hammer just vibrates it into place until it is at the same elevation of the one right next to it. That's where those white lines come in handy to know how far they have to go. We also have surveyors that are verifying its vertical location and its horizontal location to make sure it's in the right place. Once the king piles are in place and aligned, the contractor is putting in the sheet piles. You can see a picture of what a whole row of sheet piles looks like in the foreground, and then the installation of our sheet piles between the king piles in the background. So how the contractor is doing this is they are picking up each of these sheet piles off the barge, sliding them into place, then moving on to the next one. So these are as far as those piles will go just by gravity alone. Then they come back with that vibratory hammer and vibrate them so that they're at the same height as all of the king piles. As the work continues to move along, there are a few more steps to installing these walls. The video you see here was taken in January, so it's pretty cold. You can see a crew that was putting in the perimeter drain and a crew that is putting in the tie rods. During the winter, they did have to break up and remove all of the ice as they went to facilitate this work. In February, work continued on the DMMF, especially on the north face of the facility that you see on your screen. Tie rods were continued to be installed, and ice continued to be broken up on the interior and exterior of the facility and removed. In addition, unsuitable material between the walls have been removed, and more tie rods were installed, more perimeter drain was installed, and sandfill began. So you can see the crews progressing with that sandfill in the foreground. Once the sand is in place, it needs to be compacted. The contractor is using a method called vibrocompaction to do that work. These red devices that you see are vibrocompaction lances. They vibrate the sand into place and compact it. Following that compaction, they are putting crane mats down so that they can drive fully loaded dump trucks over the sand and our tie rods and not damage them. Watching the time-lapse videos is really helpful to see the progression of construction. It's also helpful to look at some still images of that same time period to really get an understanding of what we're doing. The crew in the background on the far left side of your screen is working on removing the unsuitable material from between the walls. What this will do is it will allow us to drive on this facility into the future. It adds a lot of structural stability to have the hard clays and none of that soft sediment. The crew in the middle is working on installing the perimeter drainage system, which will allow us to control the water of the facility into the future. They are also installing the tie rods, which add to the structural stability. The crew closer to the foreground, right in the middle, with the bulldozers and the skidsters, are placing sand fill. That sand fill is coming from 4 quarries in the greater Milwaukee area and is tested to make sure that it is consistent between all those 4 quarries. The crew that is working off the barge in the interior is installing dead man anchorage. This is another structural stability element and is specifically at this corner to add structural stability to that interior wall where there is some additional geotechnical concerns. That dead man anchorage system was permitted and approved by WISDOT to be placed in proximity to the Hone and the Hone Bridge Pier. The DMMF has 2 construction cameras. The images and videos that we've seen so far have mostly been from the north construction camera. This is the view from the south camera. There are a couple things to point out from this view. The first is that there is a pump station pile. This pile is much larger than the other piles because it will be the place where we will manage water using that perimeter drainage system into the future. The other thing you can see in this photo is this machine here in the middle. This machine is what will be used to install the soil mix cutoff wall, which is the main containment component of this facility. It's what prevents the migration of contaminants through the facility. It will be 2.5 to 3 foot thick around the entire perimeter and will be installed using this cutter head and mixing bentonite blast furnace slag, and fly ash with the sand to create an impermeable barrier. The contractor will be working on putting in that soil mix cutoff wall over the summer. They are planning to work a 24-hour cycle, so they will have two 12-hour shifts, and will be working overnight. We anticipate that this will allow us to complete the soil mix cutoff wall in the good weather months. Now that we talked about the Milwaukee AOC, sediment removal, and the DMMF design and construction, it's important to revisit the timeline. Design of the facility was from 2020 to 2023. Construction started in 2024 and is anticipated to be complete in late 2026, early 2027. Once the construction is complete, the facility will be turned over to the City of Milwaukee for long-term care and maintenance. Concurrently, the EPA can begin filling. We anticipate that the EPA filling will begin in approximately 2028 and complete in approximately 2031. Following that filling, that material will need time to settle. We anticipate 10 to 15 years for that settlement to happen. That timeline is largely dependent on the amount of water in the sediment that is being transported to the DMMF. Also during that time, MMSD and the Port Milwaukee will have the opportunity to fill the remainder of the facility. We anticipate that that will be anywhere from 0 to 45 years, depending on what projects and what material we identify would need to go there and what is permitted to go into the facility. 25 to 50 years from now, we anticipate capping and final cover to occur. We get asked a lot what the future use of the DMMF could be or should be, and ultimately we're leaving that decision to future generations. How we've used the waterways over the last 50 years is anticipated to be different than how people use the waterways 50 years from now. So leaving that decision to future generations seems like a really good idea. Thank you for your time today. If you have any questions, feel free to reach out through the Milwaukee Waterway Restoration Partnership.org website.